Bonjour, good morning, buenos días. Mi nombre es Dan de Ardins, CEO de Kings Distributed Systems. Hablo inglés, español, y me gustaría aprender español, but the rest of the presentation will be in English. Hopefully soon I'll be able to deliver it in Spanish. So really quickly, we are Kings Distributed Systems. We are a company based in Kingston, Ontario. I personally have a background in computational physics and in search and rescue, and we've moved over to deep tech, and we're now a 32-person company in Kingston, building software that enables high throughput computing or high performance computing systems using computers that are found in hospitals. And so that's the title of today's talk, and the application on top of this network will be smart scheduling. So this is not news to anyone. Hospitals and healthcare institutions, not just in Ontario and Canada, but all around the world, would like to adopt increasingly data-driven practices to increase efficiency. We've seen AI revolutionize or begin to revolutionize supply chains and logistics. We've seen it in smart energy, smart homes. There are even smart fridges that can predict when you're going to run out of milk. Imagine what we could do if we put smart scheduling and AI and data-driven applications in the healthcare system. However, there's a problem. Hospitals are constrained by the high cost of buying a lot of dedicated digital infrastructure, so all the supercomputers they'd have to maintain in their basements. The other alternative would be renting expensive cloud services, which also come with data governance and privacy issues. For example, I don't think any hospital in Ontario is storing data in the cloud because the top cloud providers are US based, which could pose some issues with even data sovereignty problems, Canada, US, and so on and so forth. Hospitals should not be dependent on third-party data centers, especially if they're super expensive. So how do we resolve this gap? There's a desire to do smart hospital applications, but there's one of the major barriers is IT infrastructure. So this is what we've built. Imagine if you could effortlessly turn the hundreds or thousands of computers that are mostly idle, definitely all night and during parts of the day, that are already in the hospital and they're secured by the hospital's firewall, into a high throughput computer to process a lot of the data and compute for those smart hospitals. Of course, since this is leveraging the hospital's existing digital infrastructure, there'd be no new digital infrastructure to acquire. And because again, it's the hospital's own infrastructure, the data stays in the building and it does not need the cloud. And so that's what we've built. It's called the Distributed Compute Protocol, or DCP for short. And with it, we can connect any computer using any operating system or any device already inside a hospital. This can be done in minutes. It can do huge compute, and all of the data stays in the building, and it's 10 times cheaper than cloud. So here's some examples. Oops. Some of my images, I guess. Oh, here we go. These are some of the applications that we've already deployed on DCP in hospitals. So we've done some AI augmented digital imagery diagnostics. We had a big project called Project Looking Glass, which was able to apply predictive analytics to COVID-19 case data on a municipality by municipality case situation. And it actually compared the difference of the predicted economic impacts versus public health impacts for given lockdown scenarios. We've also been able to predict COPD patient readmission. And one of the more interesting applications has been optimizing, automatically forecasting key performance indicators of different possible surgical schedules in order to pick and automatically generate the most efficient surgical schedule. All this using in-hospital compute. And so I want to talk a little bit about that one a little bit more in detail. It's called Osler, and essentially it does not replace existing EHR systems. It's more akin to a smart calendar where an administrator can say, we need this many blocks of ear, nose, and throat surgery, this many blocks of gynecology, this many blocks of ortho over the next X months. What's the best way to schedule all of these surgical blocks and surgeries such that we maximize OR utilization, minimize bottlenecks, and maximize all key performance indicators. And what that will do is it'll compute every possible permutation of schedule, apply predictive analytics based on historical OR data in the hospital, and it will generate the most efficient schedule. Like that, we're increasing hospital surgeries by about 7 to 15% using existing resources in the hospital. No need for expanding any of the current burden. Another smart application that I touched on was Looking Glass, which is applying predictive analytics to COVID-19 data. And we were able to predict with great accuracy the cases, ICU beds, deaths, and whatnot on a municipality by municipality basis. In addition to GDP impact, economic impact, in the context of different lockdown level applications. And with the Delta variant quickly spreading, this might prove useful as governments, both at the federal and municipal and provincial levels, are trying to tailor lockdown and restrictive measures that minimize GDP impact but maximize public health and safety. So that was short and sweet, but in essence, DCP is a compute platform that that enables smart hospitals without the cloud. If there are any questions whatsoever, please direct them to info@kingsds.network. Again, my name is Dan Desjardins, CEO of Kings Distributed Systems, and I would be more than happy to take any questions.
Thank you, Daniel. Very interesting project. Questions? Let's see questions in the chat.
We have one from Keith. He says, does the platform's low processing times on local computers used?
Thank you for that excellent question. The answer is, well, yes, but it runs as a screensaver. So it only runs processing tasks on computers when the screensaver is active, which means by definition, it will only be used for processing when inactive.
So maybe I can jump in and ask, when you work with a client, say in Mexico, how would that work? How do you implement such a solution in someone else's institution?
So we have 3 hospital, I call them partners, here in Ontario already. And what we've done from a technical perspective, deploying the solution is as simple as, almost as simple as deploying a Windows update to all machines simultaneously or select machines. So we have a network installer that will mass deploy a worker agent, and all data obviously stays within the building. And those work agents will accept tasks within the hospital. And then any application that is hosted in the hospital where the data is in the hospital will then talk with those workers, and they'll move compute around to be executed and then push the results into the directory, the application that's used by the client. So in this case, it was a surgery optimization. The other question from Keith, I see added cost for electricity then. Absolutely. So in Ontario, electricity is among the highest, at least it's more than Quebec, but we're still talking about half a penny per hour to run a desktop between on and idle and on and computing. So compare that to the cost of commercial cloud, it's thousands of times more. So this is definitely orders of magnitude less expensive than cloud. It's
We have
definitely
another
green.
question. It's perfect. We have another question. It says, in Mexico, public hospitals do not have enough computer hardware, or they have older ones. Could you be able to work with that?
Yes. So the technology, I didn't go deep into the tech here. I'm very happy to speak to people who are technical in the audience. We built everything on the web stack, which is completely different from the typical Docker container or virtual machine, heavy and not interoperable stuff that's out there. We're all using Zoom right now. We all use Google Docs and Google Sheets. There's one technology that works on literally everything, every device, no matter how old or how new, and it's web technology. So we've built at the core of this, it's all built on web technology, which means I've run it on a Tesla, I've run it on a fridge, I've run it on a doorbell, and on computers. And what's interesting is that the same web page or web application built in 1993 looks the same in 2021. That's because web tech is forward and backwards compatible forever and is around to stay. So is this platform, and so are the applications developed on it. And therefore, we can use computers from back in the day, even if they're still running Windows XP, which I wouldn't recommend, but it would still work. And then, so that's the first half of the question is, can we run on old stuff? Absolutely. We can run on probably smart light bulbs. It wouldn't be very efficient at computing, but it would still work. The other thing is, what if there are not enough computers in a hospital? We're able to essentially create secure groups of compute anywhere. So let's say there was a local university or high school or college. We could create a secure compute cluster there using their computers. And then we could, as long as the university and the hospital trust each other, they could burst sideways like that for the same benefits.
Wow.
And Keith, another great question. How does it relate to underserviced regions to the world using existing infrastructure? Amazing question. Right behind me, there's a banner, and you can see the name of that company is not King's Distributed Systems. It actually says Distributed Compute Labs. That's our educational nonprofit. It's a different arm of our business. It offers this technology for free to academic institutions worldwide. And we've already deployed some of this technology in Nepal, Pakistan, in Nairobi, in Kenya, and a variety of places across Canada. And we're excited to bring this to anywhere willing to test it out. And of course, being able to harness compute infrastructure that you already own isn't just for hospitals, it's for manufacturers, it's for enterprise, it's for small, medium-sized enterprises, it's for everyone.
Thank you, Dan. This is a fantastic solution. Thank you for giving us this overview. And again, if anyone wants more information, I've put the website in the chat, and you have Dan's email from, he mentioned it earlier, and maybe you can put it in the chat, Dan.